Okay, for the homework, we're going to start off by doing 1, C, E, and F. So 1C, we have 41 times 4, and we know we can rewrite that in uniform as 41 ones times 4 ones. And we know we can take 4 times 1 is 4, 4 times 4 is 16, so we have 164. And the big emphasis here is on our uniforms. 1 times 1 is ones. So we end up with 164 ones. So we know 41 times 4 is 164. And we don't normally put the ones out there. On E, we're showing 3,310. So if we want to rewrite this in tens, we're looking at the tens place. And we know that's 331 tens. Now the second one says hundreds, so we're looking at the hundreds, and we end up with 300s. So if I were to do this in a vertical format, I would be writing it like this, which allows me to go 3 times 1 is 3, and 3 times 3 is 9, and 3 times 3 is 9. So I ended up 993. But we multiplied tens times hundreds, and that's going to give us thousands, because 10 times 100 is thousands. So now we know that 3,310 times 300 is going to end up with 993 thousands. So 993 thousands. Our last one, we have 500 times 600, and we know we have 500s times 600s equals 30, because 5 times 6 is 30. But we're multiplying 100 times 100, and we're going to end up with 10,000. So it'll be 30 10,000s. So we know 500 times 600 will be 30 10,000s. Okay, on question 3, we had B, D, and E to do. So starting with B, I'm looking at this, and I'm going to combine these to see if I can make them closer. Because I know the commutative property and associative property. I can go ahead and just multiply these in any order that I wish. So I'm going to change this around to where I got 44 times 10 times 20. And that allows me to multiply 44 times 10, which gives me 440 times 20 equals 440 times 2. And I don't have to go any further than that, because I can see already that it's going to be 10 times greater. This side's going to be 10 times greater than this side here. So this would be a false statement. If we go to D, I'm going to use the same type of idea here, as I'm going to go ahead and change it around, because this one here is 640 times 8 times 10. So if I change this around, I could go 640 times 8 times 10 times 10, which allows me again to change it around, where if I did 664 times 10 times 8 times 10. Now I know 64 times 10 is 640 times 8 times 10, which happens to be exactly what I have on the other side. So this would be a true statement. Our last one, I'm comparing the two, and I know that if I multiply 57 and 10 together, I'll get 570. So I'm going to go ahead and do that. Now I have 570 times 2 times 10 remaining times 10. There were 3 times 10s here, and I did away with the 57 and this 10, which equals 570 times 2 times 10. And I can see already I've got an extra multiple of 10 in here. So this would be a false statement. So I didn't even have to work them out all the way. All I have to do is decode them and recombine using multiplication in order to see if it's a true or false statement. on 3, we had B and D to do. And the same thing here, we're going to go ahead and break them apart so that we have just basic math facts to deal with. Now, on 45 here, this is a little different, okay? We see here, we know 45 times 3 is going to be 135. So I know 3 times 5 is 15, 3 times 4 is 120, so it'll be 135. Okay. Now over here, we can break it down the same way. We do 45 times 3 times 10, which I know once again, this is going to be 135 times 10, which gives me 1,350. Over here, going a little bit further, we got 450 times 30. So we're going to go for 50 times 10 times 3 times 10, which allows us to go to, it should not be 450, it'd be 45 times 10. Now it allows us to go 45 times 3 times 10 times 10, which means we know this is 135 times 10 times 10 is going to be 100, and we ended up with 13,500. The last one, once again, we're going to go 45 times 10 times 3 times 100, which allows us to go 45 times 3 times 10 times 100, which now we know this is 135 times 1,000, because 10 times 100 is 1,000, and we have 135,000. D. On D, I know I'm multiplying by 2, so I know 2 times 8 is 16. I carry my 1. 2 times 1 is 2, and 1 is 3. 2 times 7 is 14. So I end up with 1,436. Now that we have that worked out, now we know we can break this down to 718 times 10 times 2 times 10, which gives us 718 times 2 times 10 times 10, which we just solved over here. We know that's 1436 times 10 times 10 is 100. So now we know we're going to have 1,436 hundredths. Next one is going to be the same, 718 times 10 times 2 times 100, which gives us 718 times 2 times 10 times 100, which gives us 1,436 times 1,000, which gives us 1,436. Our last problem, remember all we're doing is decode them to the multiple of 10, I mean. So there's 718 times 100 times 2 times 1,000. So that means now we got 718 times 2 times 100 times 1,000, which gives us 1,436 times, we'll get that zero better, 100,000. So now we got 1,436 times 100,000, 436, which gives us 143,600,000. And question 4, it says Ripley told his mom that multiplying whole numbers by multiples of 10 was easy because you can count the zeros in the factors and put them in the product. He used these two examples to explain the strategy. 7,000 times 600 equals 4,200,000. Instead he had 3 zeros, 2 zeros, so he ended up with 5 zeros. On the second one, he says 800 times 700 equals 560,000. said 2 zeros and 2 zeros equals 4 zeros. Ripper's mom said the strategy will not always work. Why not? Give an example. Now this goes back to when we were talking originally, and this works with whole numbers only, because basically he's just adding zeros onto the end of the whole number. Okay, if I were to take the same one and let's say add 7.1 times 20, okay, and with this one here, I can see that I have 1 0. I'm just going to put it as 10 to make it easy. Okay, so if I put a 0 on there, it'll be 7 and 1. I added a 0 on the end. But if you notice the two numbers, I have not changed the value at all, because all I did was add a 0 on the end of it. This is because the numbers actually shift, the digits actually shift to the left one place value. Whole numbers, it works out that if you just put the zeros on the end of it, they actually shift one place value. But if we took the numbers 7 and 1 times 10, and we can see we have one place value, they actually come out to be 71, not 7 1/10. The last problem says tickets to a baseball game are $20 for an adult, $15 for a student. A school buys tickets for 45 adults and 600 students. How much money does the school spend for tickets? So I'm going to go ahead and do a tape diagram. The top is the total spent on tickets. Now I'm going to split this here in half because it says they bought 45 adult tickets and they bought 600 student tickets. I know that if you add all that together, you should get the total. Now, for the adult tickets were $20 each. So I know 45 times 20 will get me how much the adult tickets were. Now down here, I know each one of the students is 15, so this is 600 times 15. Now using the strategies we just did, okay, I can do 45 times 2 times 10, which I know 45 times 2 is going to be 90 times 10, which was 900. So it costs $900 for the adult tickets. Over here, I can split it apart by doing 6 times 100 times 15. And I know I can change this to 6 times 15 times 100. 6 times 15 is going to be 90, because 6 times 10 is 60, 6 times 5 is 30, gives us 90 times 100. So we're going to end up with $9,000 for the students. Now the total is going to be 900 for the adults plus 9,000 for the students, which equals $9,900 or $9,900.